What is the strongest material in the world? Ask someone what the hardest substance is, and many will answer diamond. But in reality, several materials are even stronger than diamond. Let's explore some of the world's most durable substances. The hardest natural material. Diamond. Diamond, also known as adamantine, is the hardest naturally occurring substance on Earth. However, if you strike a diamond with a hammer, you'll find a dent on the hammer, and the diamond will shatter. In contrast, if you hit a rubber tire, it will deform and then return to its original shape without breaking. Diamonds are extremely hard and highly resistant to deformation, but they lack toughness. This means they are brittle and can fracture under strong impact. Tougher materials tend to bend rather than break under pressure. So from this perspective, diamond isn't necessarily the most durable. Cosmic upgrade, lonsdaleite. In 1967, scientists discovered a rare and extremely hard mineral in a meteorite crater in Arizona. This mineral was named lonsdaleite. When a graphite-containing meteorite enters Earth's atmosphere and crashes to the ground, the intense heat and pressure from the impact can compress the graphite into lonsdaleite. Unlike diamond, which has a cubic crystal structure, lonsdaleite has a hexagonal lattice and is often referred to as hexagonal diamond. Theoretically, pure lonsdaleite is about 58% harder than diamond. Harder than steel glass. Palladium-based metallic glass. Most types of glass are hard but brittle. However, in 2011, researchers developed a new type of metallic glass made from a microalloy of 5 elements: silver, silicon, palladium, germanium, and phosphorus. Palladium gives this glass its toughness, allowing it to deform under impact instead of breaking. This metallic glass is stronger than all forms of steel and is currently the hardest known material that doesn't contain carbon. Although difficult and expensive to manufacture today, advancements in production could one day make it possible to use this material in aircraft windows or even glass bridges. The toughest paper. Bucky paper. In the late 20th century, scientists developed carbon nanotubes, structures even harder than diamond but incredibly small, with a diameter just 1/50,000 that of a human hair. In the 21st century, researchers began to weave these nanotubes into thin sheets known as Bucky paper. It weighs only 10% as much as steel but is over 100 times stronger. Bucky paper is also fire-resistant, thermally conductive, and shields electronics from electromagnetic interference. It holds promise for use in bulletproof vests and armored vehicles. The strongest single-atom material. Graphene. Graphene consists of a single layer of carbon atoms arranged in a honeycomb pattern. It is currently the strongest and thinnest man-made material, with a strength 200 times that of steel. A graphene sheet made into a hammock could support a 4-kilogram cat while weighing only as much as one of the cat's whiskers. A graphene layer as thin as plastic wrap could theoretically hold the weight of an elephant. Graphene also excels at conducting heat and electricity, and its potential applications, from electronics and sports equipment to cars and spacecraft, are rapidly expanding. It may not be long before graphene-enhanced products become part of our daily lives. What does it mean to be strong? The strength of a material depends on several properties, including hardness and tensile strength. Simply put, if two materials are rubbed against each other, the one that causes more visible damage has higher hardness. If a material can withstand more force before breaking when stretched, it has greater strength. The most durable substances combine both high hardness and high strength. Allotropes of carbon. Diamond, lonsdaleite, graphene, and even soft graphite, used in pencil leads, are all made from carbon atoms. These are known as allotropes, different structural forms of the same element. Just as a flat sheet of paper can't stand upright but becomes much sturdier when folded or rolled, carbon atoms arranged differently form materials with vastly different properties. The atomic structure defines the hardness and strength of each allotrope, giving carbon its incredible versatility.